Hi, this is part two of my presentation on sockets and programming using sockets. So we're looking at network programming, if you remember, and we're interested in how a network client or an internet client uh, works, and we're interested also in how an internet server works, and thirdly, how both communicate with one another. So I'm going to show you all that, and then at the end of this part, I'm going to actually demonstrate by practical uh, programs. So I'll show you two programs that are actually can communicate over the internet. And as I ended part A with the conclusion that if the server actually runs on my machine, then it will run uh, anywhere in the world, and I can rely on it to communicate with the client that's running on this machine. Let's take it a bit further. So hold on to some of my quite innovative diagrams. Okay, so the title is Building on the Work, all the work that we've done on TCP and streams, because those are the two basic components. So I suppose this is something I actually already asked you to do. I wanted you to cut and paste the simple web server I gave you about 3 weeks ago, run that in Eclipse, and point your browser at the server and allow the server to send you the browser some very, very simple web page. Anyway, that's not what we're up to doing at the moment. So what we're going to do is to use streams and readers to program input and output. Well, in fact, we'll be using writers possibly to program output, or even I think we're going to use a data output stream to get control over the way in which we can output data. So remember, a stream is just an endpoint, communication endpoint that supports various methods for doing input and output. And we'll see how to create a reader that's actually formed from an input stream. So we'll do a little bit, a fair amount of programming on the way to getting the finished products. So when you see there should be a diagram here somewhere. Okay, let me see the diagram. Where's the diagram? Okay, when you see a diagram of that form, what I'm doing is to combine streams with what I call readers and maybe buffered readers or something else. And what we get is a composite which gives us the ability to read appropriate data, appropriate amounts and types of data from this incoming, I guess, communication channel. This might represent an electrical wire. It might represent a wide area network. It might represent a microwave channel, and so on. And the point about constructing this composite object, and I'll explain that in detail in a moment, is that it's going to enable us to have useful, appropriate methods for reading data in. Or maybe I'm going the other way. I mean, maybe what I want to do is to be able to write appropriate chunks of data out onto this communication channel, in which case I might be able to build using Java's output streams and so on, and Java's output stream, very simple output stream here. I mean, remember what we were talking about last in the first part of this presentation is that an input stream is very basic, and an output stream is very basic. An input stream, in Java terms, is just capable of reading a byte, one byte at a time, from an incoming communication channel. And an output stream is only capable of writing a byte or an integer to an outgoing real communication channel. And just bear that in mind. So the reason why we're constructing what appear to be elaborate amalgamations of types of stream or stream-like entities called readers and buffered readers is to enable us to program successfully using that. So the point of doing all this is that the blue stream, or the reader, what's called a reader, offers us appropriate methods for achieving what we want to be able to do, namely buffering plus a method that will actually enable us to read a line of text. So we can get, in a simple atomic operation, we can read a line of text. If this is a buffered reader, if that's a buffered reader, maybe this is going to be a reader, and maybe this is a very simple input stream, which can only only allows you to read characters at a time. The reader is character oriented. In other words, it allows you, instead of reading bytes in, it can actually read a character or possibly an array of characters. I'll have to check up on that. But the buffered reader means I can accumulate characters in a chunk and present a read operation as giving you a line of text out, which is great. It's just great. So we're going to look at all this in a little bit of, or a fair amount of detail. And what we're looking to do is to be able to program an application using a TCP socket. And as we saw in part A, a client, first of all, must contact the server. The servers should be listening to a given port. Okay, so the server must have created a socket that welcomes the client's contact. And the client contacts the server by simply creating a local socket. Well, we've seen that. And to do that, we need to specify an IP address and a port number of the server. And we need to specify the port that the server is listening on. And when the client creates, let me just move the page up a little bit. When the client creates the socket, the TCP client actually establishes or attempts to establish, we've gone all over the place, attempts to establish a connection to the server, the TCP server. And when the server is contacted by the client, the server creates a new socket for the server process to communicate with the client. Well, we've looked at that in some detail. And the creation of such a socket allows the server to talk with multiple clients very, very quickly and probably concurrently. And we use the idea of a source port, using each client having a port locally, is that the server can actually distinguish between those clients. Okay, so from an application point of view, TCP provides a reliable in-order transfer of bytes. In other words, it gives us like a stream, or a virtual stream, in which we can just push large amounts of data in a stream to a given destination, and it's reliable. In other words, if a chunk of data goes missing, there's a mechanism to recover that missing data and so on. If some data is corrupt, we can remedy that. There's absolutely no problem. So it's worth considering. I mean, if your application demands that communications be reliable. So look at this flow chart or flow diagram, and this sort of summarizes everything. So first of all, on the server side, you create a socket. Well, yeah, we know that, and it's going to listen on port X for an incoming request. And how do we do that? Well, it's simply that we can give the server's main socket a name, welcome socket, and we use server socket.x. In other words, well, actually in Java we actually write new server socket on a particular port number. And then we simply wait for an incoming request using a line such as this one. So the connection socket is going to be the result of accepting the connection in this socket. So this is the name of the server socket, and we're using the accept method, which is available to the socket, this socket that was created by the server. And so on the client side, at any point in time, we can create a socket and connect to the remote system simply by writing client socket is a new socket. And I could actually specify, if I wanted to, a particular port number that I want, a local port number on which is going to form part of my internet address. And the next thing I do, maybe I send a request using the client socket, my socket, to communicate on that. But to do that, I will need to obtain relevant streams. Okay, so I can send data to the server at that point, and I can read the request on the socket. Well, how? Well, we'll see that we've created a one-off input stream for the server to listen to incoming communications. Well, okay, that's fair enough. And as a result of reading a request, then it's likely that the server will want to reply to the message sent to us by the server, and it'll send the message, and over on this side it's going to read the incoming stream using one or more methods. I'm going to read the reply from the server. So it's okay. Well, as far as the server's concerned, job done. You know, I can just go back. So let me just show you this. I can. Wait a minute. Just having a bit of difficulty in coordinating pages at the moment. So as far when I get to this point, I've serviced the client. I've done what the client wanted, so I can quite safely and happily go back to this point where I'm waiting for a second connection request, and the whole cycle's repeated again. This time there'll be another client, and the client will actually send me a request, and I will respond to the client's request, and then I'll go around the loop and simply wait for a third request for a connection. So the only thing I want to point out here is that supposing the server receives a request from the client, maybe it is to do some very complicated task on behalf of the client, which is going to take half an hour. And the implication is, well, maybe the second client is going to have to wait at least half an hour for it to be served. So there's a bit of an issue here, but we can resolve that quite easily later on if we want to. So, so what's going on here? Well, this is an alternative representation of what I've already given you. Here's the client, here's the server. Uh, the client creates a socket. I can specify the number of the socket, don't have to though. Then I specify the server's IP address and the server's socket number, and so I'm actually putting in a request over here, and the three-way handshake takes place. And if the server accepts my request, I mean, it's a good, if it's honest and it's bona fide, then it will create a brand new one-off socket on which to communicate with me, called a connection socket. So the server can send me bytes and I can send it bytes. So that's from the top level, that's what's going on. So what I want to show you is some detail, and the first bit is that this diagram represents the architecture, the main parts of the client. Let me explain this. First of all, I want to read data that I type in from the keyboard, and I'm going to use a stream to do that. So there's data, I'm going to show you how to do this in a moment. I'm going to read data from the keyboard, lines of data in fact. Then I'm going to send them straight out to the stream, on the stream that I've created by means of creating a socket. So these two streams, an output stream and an input stream, have been created from my creating a new socket object. So what's going to happen here is that the client's going to read lines from standard input, in other words, from the from user stream, send it to the server via the socket, out to server stream. I've given it a name, out to server stream. Then the server, not the client, reads the line that I've sent it from my socket, and it's going to read it from the socket that it's created on which to talk to me. And then the server's going to do a little bit of processing, and let's supposing it does something very simple, like simply to convert the line of text I've sent it to uppercase, and then it'll send it back to me. And the client will receive the data that's been sent back on the stream called in from server. And finally, the client will print the data that's been received and just displays it on the screen, or puts it in a file, or does something with it. So that's the client TCP socket, which, as we've seen, will enable me to get two unidirectional streams from it on creation. So let's just go down a page. So let's give a little tiny bit more detail and a bit of code here. So just to repeat all this. So what I'm now focusing on is getting data in from the keyboard, and I want to create this stream-like object from which I can actually read data in order for me to then send it out on this stream here. So system.in is, take it from me, you have to accept this, is a stream available in Java that's already connected to the keyboard. And what I'm going to do is to immediately connect it, or amalgamate it, to a reader. And the reader is called input stream reader. And I'm going to create a new object of that type. So let's just look at this. Let's pause and look at this. System.in is a very simple stream. what it enables you to do is to read a byte of data from it, and then another byte, and then another. It just offers a simple method: read a byte, or maybe read an array of bytes. Okay, but what I'm going to do is to amalgamate it with a reader, and what this is going to do is to enable this new composite object to read characters, not bytes, but characters. I mean, you probably don't know anything about characters when we use them in computers, but they're ASCII characters, ASCII, American Standard something or other. Right. I mean, if you want to check out ASCII numbers, you'll find that corresponding to every 26 letters of the English alphabet, there's a byte equivalent. So an input stream reader can actually read characters. It's character oriented. The input method is character oriented. So all that this line does, and I'll give it you in full in a moment or two, it joins the system.in stream to a reader class called input stream reader. But we're not quite finished yet. We need to join this up with a buffered reader. Well, how do we do that? Well, we simply write to get the new object from which we can which we can read lines, is to create a new object, a new buffered reader object, which has been amalgamated, which has been formed from our reader. And the reader, if you remember, has just been amalgamated with a very simple input stream channel called system.in. So let me just show. I mean, don't be put off by all this. So what we've actually got, is this, something that looks like this. The reddish cylinder is our very simple system.in stream, input stream. This is our input stream reader. It enables us to read characters. Well, I'm not happy with that. I want to be able to read lines. So what we do is to buffer it. In other words, collect characters together and present them as a string. So we've got this new composite, which I can represent quite informatively by that. So have a look at this and just try and get a conceptual grip on all that. So what's the point of doing all this? Well, I've already said a buffer input stream offers a very basic input method. It can read, and what it does is to read an 8-bit byte. Input stream readers take an input stream and gives you a reader, which offers you the possibility of using a different set of methods. So input stream is byte oriented, does have a character based equivalent in the form of a reader class. Let me just move down. And we can use a buffered reader to read bigger chunks of data, if I'm allowed to put it that way. So let's see some code. So I want to show you how an input stream can be converted to a reader for easy character reading without using a simple input stream or data input stream. So I'm going to show you a little bit of programming that enables you to do this. All right, have a look at this code. And it's something I've already given you, and I ask you to sort of cut and paste this code into Eclipse, I think probably 3 weeks ago, but here it is again anyway. So what I'm doing is to use a system out.println. So this is just like a Python print statement, just prompting you to put your name in. Here I've got system in. Now if you remember that, this is a very simple input stream. I'm calling it IS, short for input stream. And then I'm going to create a new input stream reader from the input stream I've got here. So I convert that to a reader. So here it is. Here's my name for it. So I've created a new object from this class, and it's called reader. So reader is of type input stream reader. And the next step is that I can make a buffered reader from reader. This is reader. I can make a buffered reader object. How do I do that? Give it a name, buff reader, it's of type buffered reader, and it results from creating a new buffered reader object, which I've parameterized. I've given it a parameter. I want it to use my reader. And having done that, we'll create the coloured joined up cylinders I've shown you already. And so guess what? Then after having done this fairly tricky little bit of programming, if you haven't used streams before, you've got to really sort of think about what you're doing and why you're doing it. So I've got a variable called name, and it's of type string. So I'm going to assign it the value of the result of reading a line. And a read line is one of the buffered reader's methods. You can read a line of text, you can read a whole line. So what I can do, I've read something in from the keyboard. It's all put into name. I can actually output using what in effect is the Python equivalent of print, the message higher together with the value of name, and you'll get your name printed out on the screen if you've input your name. So how do we build a stream to connect to the server? So remember what we had to do. We had to create this part of the diagram, the architecture diagram. I want a stream that's going to connect to the server 3,000 miles away. How do we do that? How do I create that? I want an output stream, obviously. How do I create that? Well, maybe it's going to be very similar to what I've just done. But this time I can create a data output stream. And what I'd like you to do is just to spend a minute on Google finding out about what methods data output stream has. So I'm giving it a name, output to server, and I'm creating that by creating a new object from the data output stream class, and it's going to be composed with the simple output stream I've obtained from my socket, the socket that I created to make the connection with the server. This time we're using a data output stream. This enables us to write an array of bytes to send data. So I'm not sending a single byte at a time, which I'd have to do if I'm using a simple output stream. I can write as many bytes as I want in one single step, which is an efficient way of communicating. So first of all, remember that given a socket such as client socket, we can do either of two things: extract the input stream or extract the output stream associated with it. Okay, so let's just move on a little bit. So, for example, client socket.getOutputStream is going to return the output stream, and we can now give this to data output streams constructor. So in other words, you can plug in an input stream to create a data output stream, which gives us the write bytes method. So in other words, what's happening here is that I've got a very simple output stream, and I'm going to build this object using the data output stream class, which takes a parameter, an output stream. And this is the output stream I've obtained from my socket. So here it is. It's a particular instance of an output stream. Okay. So how do I get a data connection from the server? So remember, I'm sending. My intention is to send the server a sentence and then wait a bit, and then I'll get a sentence back from the server, which is being capitalized or changed to uppercase. How do I do that? Well, very similar techniques that I've shown you. And it looks a bit scary, but I'm going to create a buffered reader, and I'm calling it in from server, so that corresponds to the name I've given the stream up here. So I'm going to create a new buffered reader after having created a new input stream reader, which has been given the parameter input stream. The input stream I've got from my socket. So it looks a bit complicated, but I invite you to just work this out in steps. So the line I've got that I need is this. It's a new input from server. It's a buffered reader. It's a result of my creating a new object from the class buffered reader, given the parameter that I put into its constructor, which is simply an input stream reader constructed from an input stream. Right, if you don't like the look of this rather fearsome line of code, just break it up into sections. So, first of all, call the socket, is that right, input stream? I think this is, probably right. This word here should be input stream. Temp is a variable of type input stream variable, and it results from using this method found in this object, found in the socket, to give me an actual input stream. So I've got the input stream, and then I use temp1, and its type is of input stream reader, by joining up an input stream, creating an input stream reader from temp. Temp is just this simple input stream. So I join temp to an input stream reader, which I'm missing M here. And then the next line, I can create in from server, which is it's a buffered reader, in other words, from creating a new object from buffer reader with temp1 plugged in. So this is temp1. It's an input stream reader. So I'm not pretending it's going to be immediately clear, but you can put all this stuff together to get the following code. That did we look at? Well, we did it. I think we did actually look at it. Right. So here's the client. Here is a real life kicking piece of TCP code written in Java, and it's quite short actually. So I've got two variables called sentence and modified sentence, and they both can be assigned strings. Here's my buffered reader, in from user. So this I'm going to use to read data from the keyboard, and I create the socket to connect to the server. So here's the server name and the server's port on which it's going to listen. And then I create a stream-like object, data output stream called out to server, on which I can actually send data. So, and then I can create a buffered reader to read data from the server. When it comes back, I can read it in from server. And okay, so let's start everything up. So I can assign the sentence using readline on this object in from user and get a name that I've typed in from the keyboard. Then immediately I can write bytes. I can write the sentence as a sequence of bytes on out to server, and here I'm assigning to the string variable modified sentence to the result of reading a line of data received from the server. So and then all I have to do is to print that out on my screen. Whoa, sorry. So I'm just going to okay, so what have I done here? I've sent the line to the server, I've received the line back. Let me just all I have to do is to print out the message from the server. Here's the modified sentence, and then close the socket because I've finished communicating. So what I'm going to do is to try closing this presentation down for a moment or two and show you two instances of Eclipse running, and the first is running the client, and I've called it Echo Client. These are the two string variables I talked to you about. Here's the action of creating a buffered reader called in from user. Here's the action of creating a data output stream called out to server, and here is the results of. I got this twice. A new in from. Okay, for in from server is also a buffered. Sorry about this. In from server here is also a buffered object. It's a buffered reader. So this is a okay. That's got a buffered reader up here, but that's I'm buffering data received from the system .in input, the keyboard stream. So then I can read a line of data on the in from user stream. I can then I'll say that again. I can read a line from the keyboard and put that into sentence. Then I can send sentence out to the server using this stream out to server. I can write a sentence as a sequence of bytes, and then I can wait, and eventually modified sentence will be assigned to the line of text received from the server, and then just print it out. Here, the server, it's like a mirror image of all this. Okay, but what I'm doing is to create a welcome socket, and then I can forever do the following. So I'm going to accept a connection from a prospective client. Then I can create a buffered reader using the input stream that results from the socket created here in this line, and then I can send I'm not not showing you the code for processing the sentence here, but I can immediately, let me see, I've got an output stream. Okay, now I've got an output stream from the client. So I've got an input stream. Um, I've got an input stream and I've got an output stream to talk to the client. So here on this line, I'm using in from client to read a line of text. So I've sent the server some text. The server's actually going to read it, and then just wait for it. It's all worth waiting for. Then I'm going to do a little bit of processing by capitalizing uh, the sentence. So I've just given the server. So remember that client sentence is in this variable. It's an object, it's a string object, and it does actually, if you check it out on Google, it does have a method called toUpperCase. So I'm going to convert it to uppercase. Finally, I'm going to send it on this output stream out to client with a write bytes. This is the sentence I'm sending. Finish, that's all I have to do. So just to demonstrate all this, do I have a... Okay, so I'm going to run this. So watch carefully. I'm going to run it. And hopefully... Okay, so I've got echo server, blah, 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 blah. So it's not doing anything at the moment, but it's running. And the fact that this line popped up indicates that it's alive and it's running. So I'm going to run the client, and as I said, it's going to ask me to read from the keyboard. So let's see if it does that. So I'm going to run it, and well, it's not. I don't think it's telling me to write anything, but I'm going to write something. I'm going to write my name. What shall I say? I'll just send you. I'm going to send best wishes IFG class comp science 2021, and press return. See what happens, if anything. Okay, so the echo server has actually replied, and I think that's an accurate representation in uppercase of the sentence that I sent to the server. I mean, it takes a bit of work thinking about streams, but okay, we've got to, if I'm talking to a server, I've got to use an output stream of some description, and it takes a little bit of planning and thinking about what I want to do. I mean, I want to be able to send a line. I don't want to send numbers. If it was just sending the server a single number, the system would be very, very complicated. And then I want the server to read the data I've sent it, and to do that it needs to create a client socket from which it can extract or identify an input stream, and I want to buffer it. So here I'm doing all that work. I'm getting a buffered reader which will enable me to read a line on that incoming stream. This is the incoming stream, and put the results of receiving a line of text into this variable, and just do a little bit of processing, then send the result back to the client. But this is just a demonstration of principle, in the sense that the client could be asked any number of questions, and I could package all the data received from the client into like a single data communication with the server. I can send that to the server together with a request from my bank to authorize a payment, and maybe the server's actually going to, instead of just changing a line into uppercase, it's going to do a lot of processing, a lot of analysis perhaps, and then send me a full report back, which I can receive. I know how to receive that. So it's programming that's worth thinking about, and it's programming, sort of programming that's worth knowing about. And it assume, all it really assumes is a knowledge of streams and very simple knowledge of the basic programming constructs like while and arrays and so on. So okay, so I'll return if I can. Let me see if I know how to return back to the presentation I was reading from. I don't think there's very much more to it. Oh, there probably is actually. So building if you're building a server, you've got all the corresponding operations to think about. There's the code, and I've given you what in effect is a full example. And I've already sent you independently a much more complex example of a server. I've given you a simple web server. You should have that on Pharos. And later on in this document, I actually analyse performance issues. So I'll just highlight this. If you want to think about writing a high performance server, for example, I've actually spoken about the situation where a server's been asked to do something that takes quite a long time, maybe half an hour. And meanwhile, other clients might have to queue up and wait half an hour. I mean, that's very bad. I mean, it's likely that clients will actually give up out of boredom and go somewhere else to purchase information, for example. But what you can do, so listen very carefully to this, I can accept a connection. So I'm the server now, I'm the server talking. I can accept a connection, and I'm going to pass the job, the operation that I have to perform on part of the client, to a separate thread. Then immediately go back listening for another connection request. I get one very quickly, and then what do? I create a second thread and forget about it. A thread is independent, it can run independently of my knowledge, it'll do what I want it to do, what it's been programmed to do. And I can do that maybe for 5,000 times. Now the interesting thing is that perhaps from the client's point of view, it's not aware of the fact that there are 5,000 competitors all wanting the service from the server. And all the server's really been doing is to field, to capture information about the request and then pass the actual job details to a worker. And maybe I can create as many threads as I need to get the work done. So maybe I've got 500 threads all running concurrently, as though they're running at the same time. Remember, we had a session on concurrency, and talking about threads will enable a system to become concurrent, to do things concurrently. So at some point in the very near future, I'm going to show you how to write a thread, how to create a thread in Java. So okay, that's about all. I'm ready for a rest and a break. So thanks for listening.